Hey everyone, and welcome. Today we're diving into a question that seems pretty simple on the surface, but has a really fascinating answer. Why is our world this incredible patchwork of scorching deserts, frozen tundras, and pretty much everything in between? Let's get right into it. I mean, think about it, right? It's one sun, one Earth. So what's the deal? Why the huge difference between the poles and the equator? Well, the answer, as it turns out, all starts with how our planet manages its energy. All right, so to really get this, we've got to zoom out and look at the big picture. It helps to think of the Earth as having its own energy budget, a constant back and forth, a give and take with the sun. So as you can see here, there's this constant flow of energy happening. Sunlight beams down, it warms up the Earth's surface. Then, as that heat tries to radiate back out into space, our atmosphere acts kind of like an invisible blanket, trapping some of it and keeping our planet at a temperature that's, livable. And this whole process, it's called the greenhouse effect, and it is absolutely crucial. Seriously, without it, Earth would just be a frozen, lifeless rock. It's what keeps our planet's temperature in that just right zone. Okay, so the entire planet is wrapped up in this warming blanket. But that brings us right back to our original mystery, doesn't it? If that's true, why isn't it just the same temperature everywhere you go? Well, the answer, it turns out, isn't about the amount of sunlight the Earth gets. It's all about the angle at which that sunlight arrives. And we can actually understand this with a really simple analogy. Okay, so just picture this. You're holding a flashlight and you point it directly at a wall. What do you get? You get a small, really bright, super intense circle of light, right? All of that flashlight's energy is focused on one tiny spot, making it really powerful. But now, just tilt that flashlight. It's the exact same beam of light, the same amount of energy is coming out, but look at what happens. The beam spreads way out. And because that energy is now covering a much larger area, each individual spot is way less intense and the light just looks a lot dimmer. And that flashlight is a perfect model for what's happening on our planet. See, the Earth is a sphere, a ball. So sunlight hits the equator pretty much head-on. It's a direct, concentrated beam. But as you move up or down towards the poles, that same sunlight comes in at a really sharp angle, spreading all that energy out over a much wider surface. So here's the absolute crucial point. The equator gets a direct, concentrated blast of solar energy per square foot, which leads to high temperatures. The poles, they technically get the same amount of solar energy, but it's smeared across a huge area, and that results in much lower temperatures. It's all about concentration. So this simple matter of angles has these massive consequences for our planet. It literally carves the entire globe into different climate zones. This fundamental difference in how solar energy gets distributed is what creates our world's three distinct climate zones. You've got the hot tropical band wrapped around the equator, the frigid polar regions at the top and bottom, and then the temperate zones kind of sandwiched in between. Let's break that down. The tropical zone right near the equator gets that direct sunlight, so yeah, it's warm or hot pretty much all year round. The polar zones, at the very top and bottom of the world, get the most angled, spread-out light, which is why they are so bitterly cold. And then in between, you've got the temperate zones, where a lot of us live, which get a bit of both, leading to those distinct seasons with hot summers and cold winters. So what's the big takeaway here? What does this all mean? It means our entire global climate system, everything we experience, is built on this really delicate and surprisingly elegant balance. So let's just recap it real quick. It all starts with a simple fact. The Earth is round. That curve dictates the angle of the sunlight. A direct hit at the equator concentrates energy and makes things hot. An angled, glancing blow at the poles spreads that same energy out, making things cold. And that one simple difference is what gives us our entire world of different climates. It really is an amazing system, all born from simple geometry. Which leaves us with a final and pretty crucial question to think about. If this natural energy balance shaped the entire world